Video where we will solve a problem based on reciprocity theorem where we have to calculate the value of Vx due to 20 ampere current source. So here as we already discussed in the previous videos that in order to verify reciprocity theorem you have to consider the two cases, that is by interchanging your excitation and your response. So first I calculate the 20 ampere. So first I calculate the value of Vx by keeping the 20 ampere current source as it is, which is given in the question. So in order to calculate the current, in order to calculate the voltage across your minus J2 ohm impedance, so first I need to know the value of the current that is entering through this branch. So if I know the value of the current that is entering through this branch, I can calculate the voltage across this minus J2 impedance by V is equal to I into R. So first I have to calculate the current. In order to calculate the current through this branch, I have to apply my current division rule, which states that, so in order to calculate the current through this branch, so which is say I call it as Ix, let it by X, that is current entering through this branch, say call it as Ix. So Ix is equal to, by current division rule, so main current is your 20, because the same current enters up to this is obviously same. Because at this node it gets split into two ways, that is a part of current enters into this branch, another part of current enters into this branch, which is obviously then a required branch current. So 20 at an angle 0 becomes your main current, that is multiplied by, since I'm calculating the current through this branch, so my this branch which is 10 plus j5 impedance becomes my opposite branch. So 20 at an angle 0 main current into resistance of other branch, in the sense impedance of other branch, which is 10 plus j5 divided by 10 plus j5 and the calculating branch, the impedance of your calculating branch, which is plus j5 minus j2, which is, let it be right as it is, that is we get as 20 at an angle 0 multiplied by 10 plus j5 divided by 10 plus j5 plus j5 minus j2, which is 20 at an angle 0 multiplied by 10 plus j5 divided by 10 plus j8. So on calculation you get your value of current, that is Ix, that is which is flowing through this branch, is 17.460 at an angle of minus 12.094 degree amperes. So since I know the value of current that is entering through this branch, I can calculate the voltage, which is current times resistance. So Vx is nothing but Ix multiplied by, the impedance is minus J2, since I have to calculate the value voltage across this J2 impedance. So what is my current value? 17.460 at an angle of minus 12.094 degree. When multiplied by minus J2, you get a voltage value equal to 34.921 at an angle of minus 1 or 2.094 degree volts. So this is the answer for calculating the voltage of value Vx across your minus J2 ohm resistance. So this is the first case. So in my second case, I've just interchanged the position of excitation and response. I have to calculate the voltage Vx across this terminal. In order to calculate the Vx across this terminal, I should know the value of the current that is entering through this branch, that is 10 plus J5 ohm. I should know the value of current that is entering through 10 plus J5 impedance. So similarly, as discussed in the first case, by applying your current division rule, we can calculate the current that is entering through this branch. So by current division rule, let me call it as 10 plus j5 impedance, that current that is entering through your 10 plus j5 impedance is I. So main current is 20 at an angle 0. Since the current gets split at this node, it's split into two paths, that is a part of it enters into j5 and then transfers across its 10 plus j5 impedance. So 20 at an angle 0. So my opposite impedance will be minus G2 ohm, since I'm calculating the current through this hole. So multiplied by minus J2, so divided by minus G2 plus G5 plus 10 plus G5, which will be 20 at an angle 0, multiplied by minus G2 divided by 10 plus G8, G5 plus G5, G10, and minus G2 is plus G8. So on calculation, which is I've already set into the complex mode, 20 at an angle 0, then multiplied by minus 2i divided by 10 plus 8i. So here you get the value equal to 3.1234 at an angle of minus 128.659. That is the current through your 10 plus G5 impedance is degree, and obviously in terms of ampere. So in order to calculate the current Vx, I mean the voltage Vx, so voltage is simply current through your 10 plus J5 multiply the whole impedance, that is 10 plus J5. So since I know the value of current, which is 3.1234 at an angle of minus 128.659 multiplied by 10 plus J5, which is, so multiplied by 10 plus 5i, which will give me a voltage value equal to 34.921 at an angle of minus 1 or 2.094 volts, obviously a degree. So as you can see here, the voltage value of the voltage which was discussed in the first case is same as that of voltage now getting the answer as in second case. So since the value of the voltage are being same, we can conclude that verified reciprocity theorem is been verified, and the value of the Vx is obviously calculated. So this is how the problem is solved. Thank you.